Hi, and welcome to the Early Fall 2017 Teacher Webinar. I'm Ellen Egley, and I'm the Director of Education here at STEM Jobs. I was a teacher, and then after leaving public education, I worked for an online math company for about 7 years before joining the STEM Jobs team. And with me is Jill Cataldi.
And I am a lesson plan writer for the magazine, and I have been in the education field for 12 years as well, and worked as an online math teacher also for about 7.5 years. And so now we work on writing lesson plans.
Thank you. So thank you for joining us. Basically what we hope this session will do for you is serve as a teacher's guide to the Early Fall 17 edition of STEM Jobs magazine and kind of help you see how to integrate it into your classroom and how to discuss it with your students in a really meaningful way. So that's our goal today. So hopefully you have some actionable things you can take with you at the end of this webinar. So we're just going to walk you through the issue and through the lesson plans that go along with some of the articles, but please remember that additional lesson plans are available online as well. And if you ever need that link, you can email us directly at info@stemjobs.com and we'll be happy to send it to you. So at the beginning of the magazine, we always do the STEM Myths Busted section. And this one was very timely, given some recent events at Google, as well as Uber and some other leading tech companies. So we felt it was really important to address some misconceptions about gender and STEM ability. We strongly agree with Sally Ride, who said you can't be what you can't see. So we make a really concerted effort here at STEM Jobs to feature women and people of color who are STEM professionals so that our students can start to see themselves in those STEM fields. So the STEM Myths Busted section this time is addressing the myth that girls aren't well suited for STEM careers. And this might even be a bias that you have that you're not aware of and that you're inadvertently transferring to your students. So that section is very important. And it can be a little bit awkward to have conversations about gender stereotypes with your students, especially at the middle school age and even the high school age. But it's an important conversation, I think, for you to have with them, not only for your own understanding, but for them to be able to address some of those misconceptions.
Yeah, absolutely.
So we'll let you take a look at that section on your own. Next comes the STEM Jobs Approved Colleges list. Only the top 50 are listed here in the magazine. The rest are all available online. Obviously in print we do not have room for our nearly 1,000 STEM Jobs Approved colleges. And just to be clear, because this is a question we get really often, the way these colleges are chosen is based on publicly available data regarding 4 specific criteria that we look at, which is that their programs align with high-paying jobs that are in high demand. They have programs, resources, and relationships that help their students actually get jobs. So we take a really close look at job placement rates, not just graduation rates. The diversity piece that we talked about a minute ago, are they actively pursuing and supporting diverse staff, faculty, and students? And do they have specific resources dedicated to supporting STEM student achievement and success? So what we've seen in the past is some schools taking a lot of pride in what they called their wipeout rate, which is they had really aggressive programs that eliminated 90% of the initial students who enrolled in the program. And they were really proud of that wipeout rate because it showed how rigorous and difficult their program is. Instead, we're looking for schools that actually support their students and give them the tools they need to be successful. So you can take a look at the list here. What I like about the list this year is that we organized it by state within the rank. So students can really easily see which state each of the top 50 are in so that they can find schools that are close to them a little bit more easily. So that we did that change based on some teacher feedback that we got this year. So then once we get into the meat of the magazine, our theme this year is the ABCs of STEM. So this first issue takes a look at the first 4 letters of the alphabet. And for A, we chose architecture. So we interviewed a woman named Jara and talked a lot about what sparked her interest in a career in architecture, what path she took to get to her current career, and how she uses STEM every day to be successful. So she is a structural engineer, not an architect. And that's one of the misconceptions we wanted to address by doing architecture over some of the other A fields, is that architect is not the only job in architecture.
Right.
So we talk a lot about her advice for students who might be interested in a career in architecture, and she does a great job of explaining all of the different professions that are available
Yes, she does.
within the architectural field. So Jill, you actually wrote one of the lesson plans
did.
around architecture.
I
Can
did.
you walk us through it?
Sure. So I put together a lesson plan to have students work in 2 different teams to design a room within the school district, so that they could design a different room. Maybe you needed a new layout for the cafeteria or for your gym or just like for your regular classroom, so students would focus on the dimensions that they would need for that. You could take into consideration you need the blueprints, you could use a CAD drawing, what would the floor layout be, how would these changes benefit the school or the classroom, and then students could make a 3-dimensional model to show their design and know all of the measurements. So that's incorporating, they have to do the structure and they have to have a design and know all of the dimensions. What is this measurement? What would this measurement need to be? What would the capacity fit into the room? How tall could this be? Or, all of the different dimensions. And it really looks at the bigger picture of what all could go in to designing something like as an overall building. So just focusing on just one specific classroom. And that would kind of give an example of what would go into a larger model or the whole school or something like that.
Right, and what I really liked about this lesson plan is that it gives students an opportunity to think about their own interaction with their school building.
Mm-hmm.
Where are the pain points? Where are the
Absolutely.
traffic jams? What isn't functioning well for them?
Yep.
And actually address that. So I even think of this as a really nice Genius Hour or even Makerspace activities where students can use household materials to actually build a model of the room that they're redesigning.
Yes.
And think about what problem exists with its current functionality and how they want to solve it. So I really like that it allowed some creativity and some problem solving, as well as figuring out the proportion and keeping everything to scale and all the structural issues at play. So it's a nice way to integrate the arts and the creativity into it as well.
Oh, absolutely.
So then after the interview with Jara is the architecture job spread. And then we go into B, which is broadcasting for this issue. And we did 2 separate interviews in broadcasting. One with an associate professor who had a long career in broadcasting before becoming an associate professor. And she talks a lot about what she does with her students to develop broadcasting skills and all of the STEM careers that have to happen behind the scenes to make any television or radio broadcast successful.
Right.
And then we also spoke with a woman, named Lara, who is a mobile unit engineer, which is something I know I never thought about at all until we spoke with her. And what she does is actually puts together the mobile units that go out for news broadcasts, for events, anything like that.
Right.
And what they do is start with an empty truck and think about all the equipment that they need, plan out how it should fit, how it should work. And the whole goal is that as a mobile unit engineer, not only have you built the truck, but if something breaks or isn't functioning properly, you then have the inherent knowledge to be able to fix it or create a workaround on the fly while you're at an event or while you're doing a live broadcast, which again is something that I know I've never thought about while watching a live weather report or someone at a sporting event or a concert delivering a story about it. You never think about the technology that goes behind actually allowing the signal to get from where they are to my television in my home. So that's a really interesting career path that I think a lot of our students have no idea exists, because if we as adults didn't think of it, chances are that our middle and high school students are pretty oblivious as well. So the broadcasting lesson plans are available on our website. Again, if you don't have the link, email us info@stemjobs.com and we'll be happy to send it to you. But basically we try really hard to help students actually experience what a day in the life of these professionals is like, and actually think about some of the issues that you would have to tackle if you had one of these jobs, and how STEM could help you be successful.
Right.
So after the broadcasting job spread is something we were really excited about, which is our interview with Reshma, who is the founder of Girls Who Code.
Yes.
And she is an incredibly passionate, successful person who basically, when one thing in her life went horribly wrong, was able to use what others perceived as a failure and turn it into a really positive experience that has now benefited thousands of girls across the country, with the possibility of impacting many more in the future by starting the foundation called Girls Who Code, which does a lot of after school and summer camps to teach girls how to code, to help women stop being so underrepresented, especially in computer science. So a really neat story with her. It was very exciting to talk to her and kind of pick her brain.
I'm sure.
And what I think is the most interesting is that Reshma herself does not know how to code.
Yeah, I saw that.
But she doesn't let that stop her helping other people learn how to code, because she sees it as a barrier for students who are looking to enter the workforce. So she is learning to code herself now through their
fantastic.
programs, but she started this because she saw a need before she herself even knew how to code. And I think that really spoke to me, because so often you're afraid that you can't help with something because you're not smart enough, you're not skilled enough, you're not an expert in that field, but you don't have to be an expert to make a difference in the life of someone else.
Right.
So that was a very moving story for me, and obviously for all the girls that the
Yeah, it's
program
very
has
inspirational.
impacted.
It's wonderful.
So next comes the chemistry section, which Jill and I commented is huge compared to the rest of the magazine. So we interviewed 4 different professionals. We really could have done an entire issue around chemistry, because it is such a broad
Absolutely, yeah.
field, obviously. So we tried really hard to find 4 extremely different professionals doing very different things in the world of chemistry. So I think if I was teaching the chemistry section, or any article from the chemistry section in my classroom, I would take a moment to talk with my students about what they think a chemist is, what they think a chemist does, because I think we all have very limited understandings
Sure.
of what it means to be a
And
chemist.
it's such a broad, there's so many things that a chemist can do, or that you can even study in chemistry. And you think of school chemistry, and it's very limited, and
Right.
for such a broad topic. So
Exactly. So we don't want students to be feel pigeonholed about
Right.
what it means to be a chemist. We want them to know that there are jobs in the beauty industry, in the dietary industry, in basically every industry that involves chemistry to some extent. Even technology, a lot of the biometrics and things that our wearable tech use are based in chemistry.
Sure.
So it's a really broad field that's very exciting to a lot of students once they realize the opportunities it can offer. But if we let them maintain kind of a pigeonholed view of it, they don't see themselves as someone, who works in the lab and wears safety goggles all day,
Right.
playing with a Bunsen burner. So we have to work really hard and very intentionally to kind of overcome that stereotype that so many children have about what it means to be a chemist. So we interviewed Lauren, who is an environmental scientist, and she works on water purification and does a lot of things that, again, I think we never really think about how the water that comes out of our faucets reaches us and is healthy. And
I'm thankful for it.
absolutely, but something
That
we
you don't
tend to
think of
take
the
for
process.
granted here
Right.
because water is not an issue. Now, the Flint water
Right.
crisis at least brought a little bit
Yes,
of
it
attention
did.
to it, but I think in general, we all have a very limited understanding of the processes in place to make sure that water that comes through our pipes into our homes is safe to use, safe to drink, and what that process looks like. So we also interviewed Sylvia, who is a research chemist, and her degree is in bioinorganic chemistry, which, again, I fully admit I did not know was a program. But I loved this interview with Sylvia, because at one point she actually talks about the inspiration that she and her colleagues get from nature, and it's something called biomimetics, where chemists are actually trying to mimic systems that are found in nature to solve problems in industry. So the example she gave is that they are trying to put a coating on airplanes to make the outside of the airplane function like an eggplant, which is genetically very easy to keep itself cool. Eggplants can thrive because they keep the insides of the eggplants cool based on the compounds that are on the outside of the eggplant. So they're actually trying to translate that into a coating to put on airplanes so that airlines don't have to spend as much on air conditioning as planes are waiting on the tarmac, as well as it would help protect the painting on the outside of the aircraft. So just crazy things that you never thought about, but basically trying to take inspiration from things that function well in nature and applying it to really corporate and industry problems. Again, something I never would have thought of, and I was in complete awe of as I talked with Sylvia. Next, we interviewed Ashley Walters, who is the president of an industrial furnace company. And I have to admit, when we first started talking with Ashley, I had a moment of, wait a minute, what chemistry is involved in an industrial furnace company? But as we spoke, and she talked a lot about the combustion process that takes place inside a furnace, that is all chemistry.
Yes, it is.
There's a reason that Bunsen burners are found in your chemistry classes, and it's because combustion is a chemical reaction, and all kinds of awesome things are connected to it. So again, I think that's a really good place to start talking with students. It's just ask, where on earth do you find chemistry in a furnace, whether it be a furnace in your home or a furnace in an industrial setting, and see what ideas they have, and open up that door to conversation and to creativity and to thoughtfulness. I think too often, and I don't mean to get preachy here, and I apologize for that, but our students are used to being spoon-fed, where we ask them a very specific question that has one very obvious right answer, where if they've been reading their textbook or taking notes, the answer should be obvious to them. So I think as many times as possible, we should try to challenge students to come up with their own ideas where there is no right or wrong answer, but just let them kind of explore their own background knowledge and apply it to the topic at hand. And I think too often, because of the pace of the school year, and you feel frazzled that you have to cover as many standards as possible before the standardized testing process begins, we lose the opportunity to have those kind of conversations in our classrooms, unfortunately. So I would encourage you to have conversations, and I think this story is a great segue into a conversation like that. So then the fourth chemist that we interviewed is the executive director of a joint university microelectronics program. And his name is Todd, and I have to admit that I struggled a little bit with this article because a lot of the things he said were simply above my understanding. He does a lot with nanotechnology and microchips and processors and things like that. So I had to read his responses several times to be able to translate them into terminology that first I could understand and then that our students would find to be accessible. So once I got past kind of the jargon and the feeling of inadequacy that I had reading his responses, I think his article, perhaps more than any other in the chemistry section, gives you a better sense of how broad chemistry actually is and its implications in things like technology and other fields, and really how important it is to our current way of life in ways that we never really stopped to think about. So taking a look at the lesson plan that goes along with the chemistry section, the one that came in your toolkits is actually focused on the first article, which was on water purification, and what I love about this lesson plan is that it addresses so many different types of standards all in one activity. And that's really what we believe at STEM Jobs that STEM should be, which is an integrated approach, not the siloing of separate STEM subjects, but an integrated approach that shows the relationships between science and engineering and math and how they all work together in a really iterative process, and that they cannot be taught or thought about in isolation. So that's what I love about this activity, where basically teachers are given some instruction about some household materials to use to create a contaminated water sample.
Mm-hmm.
Students are broken into groups. Each group gets a portion of that water sample and then uses household materials to build a water filtration system to try to get that gross looking water back to a state of drinkability. And we measure pH and also its conductivity to test it to make sure that it is safe to drink. So students present their designs, and then, like I said, it needs to be an iterative process. So they take the feedback, they take what they've seen in other people's designs, and try to rework it to come up with the best design possible. Then they're given a region of the world, either they selected or they're assigned one by their teacher, where access to clean, drinkable water is a problem. And they research what that geographical area's issue is with water, and try to come up with a device that's affordable and that can help solve the issue in that region. So just a really neat design activity. Again, feels like a makerspace connection if your school has a makerspace available. The only non-household material included in the entire list is activated charcoal, but that's still pretty easy to find and very affordable. So we try really hard to make sure that we only use materials that you have easy access to complete any of our lesson plans. So that's a really exciting one that I think will not only help students' engineering abilities develop a little bit, help build their confidence a little bit, but also create a sense of what life is like in other parts of the world, what the challenges are in other parts of the world, develop that connectivity and empathy that I think is hard to address sometimes in our STEM classes. We think of that as a humanities or a literature or social studies kind of a goal. But so many of the world's problems that are solved by STEM have to start with an understanding of what the challenges are in those regions. So I think it's a really nice activity that integrates a lot of different things and can be done very easily within a classroom. So then the final industry we look at in this issue is dietary, which is a fancy word for nutrition or dietetics or any of those, food, basically. I know I love food, although if you read my letter at the beginning, you know I do not like pumpkin-flavored things, which tend to taste very artificial to me. But anything else, basically, that's food is right up my alley. So for so many students, I think with things like the Food Network and the Cooking Channel and things like that, food has become a really important part of our culture. Not just eating to survive, but using cooking as a form of expression, as a piece of art, and as a way to entertain and to share and to express, your passion not only for food but for the people you're with. So we interviewed a dietitian named Melanie, who works specifically with dialysis patients to help them cope with diabetes, make good nutritional choices to help them control their diabetes. And she talked a lot about how difficult it is to become a dietitian, which surprised me. I always kind of thought of nutritionists and dietitians, I guess, as being, fairly common, I guess, and oftentimes conflicting because you feel like, there's a new diet fad, there's a new thing you shouldn't eat every month, basically, that comes out, and then the thing that they said last month is now good for you again. So I guess to me, from a very personal standpoint, nutrition and dietetics seem less of a science and more of a trend at times. But hearing Melanie talk about all of the examination and certification processes she has to go through to be a registered dietitian was really eye-opening for me. And I think there are a lot of people, who have their own wellness blogs and things like that have perhaps corrupted what a real dietitian or nutritionist does. But seeing how professional Melanie is, how focused she is on helping her patients live better and truly longer lives by making the right food choices to cope with their illness, was very inspiring and eye-opening to me. Because I don't think, while there are certain fads that come and go in nutrition and in wellness, solid nutritional advice seems unwavering to me. And the fact that your food choices do make a really profound impact on your health, especially when you're struggling with a chronic illness or a disease, is something that we can't take for granted. So then the lesson plan developed for the dietary section is a very natural extension of the article, as all of them try to be, where basically students are broken into groups and take on the role of a dietitian in their schools. So they research the different food groups, what's offered, what's recommended, and they put together a 1-week meal plan for their peers based on the offerings of their cafeteria. So whether they look at breakfast or lunch, they're asked to put together a 1-week meal plan. And they're also asked to talk about what are some of the barriers that would stop their peers from adopting this meal plan. So I think we all know what good health decisions are and what bad health decisions are. But it is sometimes hard to make the right choices.
Very much so.
And that's for us as adults. So you can imagine, as an 11, 12, 17-year-old, there are a lot of factors that go into why students make the decisions they do about their own bodies, about their health choices. So students are asked to have a very frank conversation about that. What is perceived as being normal for a child of their age. What are the peer pressures around that? What are the expectations of how teens are expected to eat, to interact with food, and that kind of thing. So a really robust lesson plan there. And then once they present their meal plans to their peers in their classroom, they are asked to come up with a way to share that meal plan with anyone else in their school building. And we really recommend that teachers leave that up to the students, because we want it to be a vehicle that they think will be most effective in delivering their message. So based on their school culture, maybe it would be a poster hanging in the cafeteria. Maybe it would be a segment on the morning announcements. Maybe it would be a clip on their TV show if their district has that capability. Maybe it's a pamphlet that they hand out. Maybe it's a little segment of an assembly. So they're asked to come up with what vehicle they think would work best for their building, and then actually implement it. And then kind of come back again, as we've talked to STEM, in and of itself is very iterative. So what worked, what didn't, why, and have they seen any changes as a result? And then the elaborate activity, has students make up a meal plan for someone dealing with a chronic illness or a disease, perhaps Crohn's disease, diabetes, HIV and AIDS. And again, we recommend that teachers allow students to choose where to focus, because perhaps they have a family member struggling with something. And anytime you can make personal connections, you make the concept much more meaningful for your students. So those are the 4 main lesson plans that come in the classroom toolkit. And then we have additional lesson plans available online. Oh, and the 4th lesson plan, we only touched on 3 of them here, is exploring careers. And basically, we have students look at each of the job spreads, pick one job to investigate in much greater depth. At the middle school level, we ask them what classes should they be taking at the high school level to prepare them for the postgraduate training necessary for the career that they're researching. At the high school level, and at the middle school level, we have them research what type of training is needed, what schools or facilities near them offer that training, what is the tuition cost, what is the length of the program, what is the job placement rate, what is the graduation rate at 3 of those facilities. And then they also look at the starting salary and the median salary of that career. And we actually have them calculate how many years they would have to work at the starting salary to pay off what they've spent on tuition, room and board, books, all of that. Because we think that's something that even adults struggle with. Oh, what is the return on investment? How long do I need to work to pay off these loans? What do I need to earn to pay off these loans in a timely fashion? Things like that I think are often left out of the continuing education conversation. So we really want students to feel empowered to know not only what careers are out there, which is a huge part of what STEM Jobs does, is trying to expose students to the career options available in the real world, but also let them see how they'll get there, not just what path to take, but what that path could cost and how they'll pay it off once they're done with it. So the Career Explorations lesson plan will be with every issue this year,
Yes.
just like last year. So it's in your toolkit this year, and after that you can find it online with our other digital lesson plans. So that kind of wraps it up for the early fall issue. The next issue, late fall 17, covers letters E, which is emergency response, F for forestry, G for geology,
Okay.
and H is hydroponics. So we'll be taking a look at those industries, and we hope to see you back for another webinar at that time. Thank you so much for your attention, and have a great day.